Welcome to part 3 of how to make a MIDI router using Python. In the last video we got our script handling the note off event so that the note will be sustained until we press the key again. In this video we're going to start coding in our control sweep functionality. If you'd like to download the code from my GitHub page, again it's available for this video. Let's pick it up where we left off. Okay, so we're now in a place where we can start coding in our functionality for the control sweep. So within the Arturia callback here, I'm just going to change this now so it says control sweep, and just get that running a moment. I just want to remind us of what we want to do here. So let's say I've got this knob here and I want to kind of scan through here. Yep. I want to automate that kind of transition. So how can we do that within Python? Well, the first thing to do is say, I want this transition to happen when I hit a pad. So let's just find out what the note values are for our pads here. So you can see here that that note on event had a note value of 0. The second pad along, a note value of 1, 2, 3, and so on. So these are actually the note values. If you remember back here, we had C minus 1, C sharp minus 1, and so on. I've mapped those note values there. So what we could say is, if we've got a note value within that range, I want to call a function called control sweep. So if message type is equal to note on, we'll ignore the note off event, and data byte 1 is greater than or equal to, let's just copy that whole part there, so speed us along here. So it needs to be C minus 1, and we'll say it's less than B minus 1. I can't remember exactly where the pads go to, but certainly we're not going to be using any notes in that range for anything else. So if that's the case, I want to call a function which I'll name control sweep. I'm not sure what argument it needs yet, so we'll worry about that in a minute. But I now need to, and once I've called that function, I'll return so that it doesn't go on any further within this callback. So let's now define a new function down here. I'll call this one control sweep. And again, I'll work out what the parameters are of this in a minute. So just to see that this is running, let's just write print you have called the control sweep function. Okay, now in theory, if I start this up again, okay, so that's still working, hit a pad, there we go, you have called the control sweep. So this is calling the function correctly. Now let's just work out what we actually want to do within this function. Depending on which pad is pressed, I want to automate a sweep for one of the parameters within Ableton here. So if you remember send A here, if I just move that dial here, I want to maybe automate that, I want to automate that, or maybe automate the filter cutoff there. So how can I do that? Well, back in VS Code, let's just have a look. When I move this rotary knob, you can see that it is sending hexadecimal B2. Okay, now what is a B message? If we just jump back over here to our message types, a B message is a control change. So I want to make a control change. For control changes, this first data byte here will be the CC number for that control. It's like the identifier, the ID number for that control. This is the value. So when I'm sweeping through, if I just keep moving that, you can see that the value is going up there. Okay, so now we know that, it would be useful, wouldn't it, to be able to have some kind of way of joining this pad with that knob there. So how can I do that? Well, the easiest way is probably to just make another dictionary here. And to keep it simple, let's call this pad map equals. So for the key, I'm just going to use the actual note value. So rather than using C-1, I'll use the value 0 in this case, just to keep it simple for us. And 0 corresponds with this knob here, which is CC number 102. Okay, let's just format that a bit more. Okay, copy that down. Now, what about the second knob? Okay, that's 103. Yeah, and third pad will be 104. Okay, so that's just mapped our different pads together here. We might want to make a note to ourselves. In fact, let's just make this a one-liner a minute for us. So we've got that, and that. Just make it a little bit clearer for us, because then I can just leave a note for ourselves to say what the different things are. So we can say that the key is the note, it's a note value for the pad, and the value is equal to the CC of the knob. Okay, so that just keeps it straightforward for us. So within our control sweep function, what I'd like to do is somehow work out which of those knobs do I need to turn. So let's have a new variable. I'll call this one sweep CC equals, and depending on what the note coming in is, remember the note coming in must be data byte 1. So let's just say, let's use pad map. Okay, it's going to be 0, 1 or 2, and that will be defined by coming in data byte 1. So I just need to use data byte 1 here as a parameter within this function. I think I'm going to need status byte as well, so let's just put that in right now. So status byte and data byte 1 are going to need to come in. Probably don't need data byte 2 for this one yet, so just back in the Arturia callback here, where I'm calling the control sweep, I'm just going to send those in as arguments as well. So now, because in this case data byte 1 might actually not be in the pad, we could get an error. Let me just show this a minute. So if I print sweep CC, let's run this code. So if I hit the first pad, it should return, yeah, 102, perfect. Second one should return 103, that's fine. And the third one should return 104, but this one should error. Yeah. Now the reason this is erroring is because it can't find, within our pad map, it can't find our data byte 1 value. So in order to, let's just clear this. In order to make sure that this doesn't happen, let's use the get method this time. So .get, and I could return a default value here like other, but I don't need to here. In fact, the default is none, and that will work out well for us because what it allows us to do is say something like if sweep CC is truthy, meaning that it's got a value, it's not none or false or something like that, then let's just, yeah, we'll print that CC there. And if it's not in there, just for the time being, let's print not in pad map, just so that we can check this is working. So let's run it again. So yeah, that's fine. This one shouldn't be in. Okay, not in pad map, and you can see it's not erroring anymore. So that's all working well now. So I'll just change that to say return. So if it's not in our sweep CC, return. So sweep CC is none, it will just return, it doesn't need to do anything more. Okay, at this point, I want to start programming in my sweep. So why don't we set up a for loop? So we can say for I in range. Now I want to go all the way up to value 127 from 0. So why don't we say 128, because it's in Python ranges like that, they're not inclusive. So that'll go as far as 127 for us. Let's just print the fact that I want to send a message. So just so we can see it doing its thing in the console here. Why don't we say what the CC is? So the CC is sweep CC, and the value is, it's going to be I. Okay. Now we also want to send out a MIDI message. So how do we do that? So MIDI out dot send message. Now if you remember, we want to send a list. We normally use status byte, data byte 1 and data byte 2 in this list. But what are we going to need here? Well, we're going to need to send a control change message, aren't we? So let's just head up to our message types here. Control change message is hexadecimal B. We're receiving a note on event. So probably the easiest thing to do here is just take what we already know to be our status byte and add a value of 16 and 16 again would give us a control change. So if I just go to status byte plus 32, that will mean that we've now changed it from a note on event to a control change event on the same MIDI channel. Okay. Data byte 1. Now for data byte 1, we need to pass in the CC number, which remember we've just worked out using the sweep CC function here. So copy that and I'll put that there. And for data byte 2, we're going to use I. Okay, so this is going to scroll through from 0 through to 127. So let's just start our script again and run it. So I'll just go into Ableton and see whether this is doing anything. So let's just turn this down a little bit. Okay, you can see that the note's running. I'm going to hit the pad. There you go. Now that did in fact cycle very, very quickly through all our values. If I go back into VS Code here and we'll have a look at what it's done, can you see that it has gone through all the values, from 0 all the way to 127 before it exited. Okay, that was way too quick though. We need to slow it down. So how can we slow it down? Well, there is a Python library called time, which we can import. So let's just go back up to the top of our script here. And I'm just going to put in here, comma, and then time. So we're going to import in a new library here called time. And this allows us to call a method called sleep. So time.sleep, which will effectively just wait for a little bit. Now, how long do we want to wait for? I don't know. Let's try a number 0.1 to begin with and see whether that works. So this will be, so a value of 1 is a second, so this will be a tenth of a second. So let's just try it now. So restart the script, I'll get that running, and then there we go. You can see this is going now much slower through, sweeping through the value. If I go into Ableton, we'll just see it gradually moving up there. Turn that off. Okay, so we've got a basic sweep functionality working now. I mean, clearly at the minute, it always starts at 0 and it always ends at 127. But we've got a bigger problem on our hands here. So let me show you this. If I was to start a pad going, let's just turn this down, and then I'll start another pad going. Okay, and now I'm going to start a sweep going. I'm going to try and start another pad going. It won't do it yet. Can you hear it hasn't fired that third one yet? Only fired it now. So what it did there is it looped through the whole range and it was kind of locked into this loop. Python wouldn't do anything else until this loop had finished. Now that's a problem, because what if I want other messages going on here? So for example, let's get this pad going again. And now I'm just pressing some keys down on the Kawai. You can see the Kawai is alright, but this Arturia function here is locked. Okay, so it's not ideal. I might want to do some other stuff on the Arturia. So although it's not affecting the Kawai at all, it is affecting the Arturia. So we're going to need some get around for that. So in the next section of the video, we're going to try and problem solve that issue there. Okay, so in this section, let's try and problem solve that issue of the Arturia callback being locked and not able to do anything else. And the way that we're going to get around this problem is we're going to use threading. So in order to do this, we're going to need to go up to the top of the script here and just import another Python library. Again, this one comes as standard within Python, so we're not going to need to download anything else for this. Now, what threading allows us to do is to run multiple things at the same time. And I'm going to go back into the Arturia callback here. And rather than just sending this function as a normal function, what I want to do instead, it's this function here. I want to send this as a separate thread. We can do that like this. Let's define a variable t. And we'll call this, t is going to be our thread. So we'll write threading dot thread. Now, in terms of what we need to pass in here, we need to first of all tell it which function we're going to pass in. So let's put in target. So you can see here, target is the callable object to be invoked when we run our thread. So target equals, this is going to be the name of our function here. Now, because I've also got some arguments that I need to send in with this, I'm going to use another one of the parameters for our threading, for our thread method here, the arguments that we need to pass in. So we're going to pass in status byte, and we're going to pass in data byte 1. Okay. So I'll get rid of this line now. Well, in fact, for the minute, I'll code it out. Now, we haven't actually started our thread yet. If we do this, it won't work. We need to start the thread. So I'm just going to write t.start to get that going. Now let's try running it again now and see whether it works. So got it running, and now let's press pad. So I've just realized this is a function. So let's not forget the parentheses. So let's try running this again. And hit the pad. Wonderful. Now, you can see, yeah, I'm able to add all the other notes here. Wonderful. Okay, so now I've got around that problem. Here's another interesting issue though. What about if I hit the pad multiple times? So let's just turn the value down here, and I'll show you what this is doing in Ableton. So press the key and hit the pad. You can see it's moving up. If I hit the pad again, what happens? Oh, what's going on there? If you look back in VS Code, right, let's just turn that off a minute. So what it was actually doing here was it was running two things at the same time, and they were competing. So you can see that it keeps flitting between the two values here. So to begin with, it was all working nice and fine. It's just rising steadily along here. And then we got to this point where I hit the pad again. And at this moment, now you can see that it's competing. So it had reached as far as 49 and then 50 before we kicked in with doing the sweep again at the same time. So now it's flitting between 151, 252 and so on. So clearly a lot of the time you're not going to want that functionality. You're probably more going to want to turn it off. So how are we going to do that? Well, similar to how we did the held notes to turn them off and on, we could do a similar thing here, couldn't we, with the threads. So why don't I add a new variable here, and I'll call this threads. And what should we record in this one? Let's record the sweep CC. Remember, this is our CC number, our control ID, if you like, that we're going to be moving. So if we've got this logged in a threads dictionary here, then that just means that we can cancel a thread if we need to, if it's already running. So now, back in our control sweep function, before we actually start this loop, the first thing we need to do is check whether it's already running. So just as we did before, if sweep CC is in our threads dictionary, then what do I want to do? I want to stop the sweep, and we'll code that in a minute. Else, we want to start a new sweep. So we're going to need to keep our threads list up to date, aren't we? So let's say if I want to stop the thread, then I'll go threads.remove, and remember we're removing sweep CC. If I want to start a sweep, threads.append sweep CC. So that will keep our threads up to date. And now, just before I forget as well, there's one other instance when we're going to want to remove our thread. That is, what if it gets to the very end and completes? Well, I guess we don't want it to remain in our threads list then. So I'll just copy this over as well, so that if it does reach the end without being interrupted, then we can remove the thread like that. So if sweep CC is in threads, then remove it from threads, and we'll just return out this function. And we're going to tweak our loop here. Let's just move all that over. You see, I will want to break out of this loop if we should no longer be doing the sweep. So how can we do that? Well, let's do a check first of all to see if sweep CC is in threads. And in fact, we need to see if it's not in threads. So if it's not in our threads list, then what do we want to do? We want to break out of this loop. And in fact, we want to break out of this function. So let's just go return. So let's now see if this is working as we expect it to. Restart the script. Okay. So let's try firing this pad. I'll open up Ableton so we can see what it's doing. Okay, so that's working fine. You can hear it coming in. And I'll just press it again. And it stopped it there, look. Perfect. If I hit it again, it starts from the bottom again. Okay, exactly what we want it to do. So back in VS Code, we can see, yeah, it stops that sweep as soon as we press it again. So that's all working great. In the next section, let's add some velocity sensitivity to our pad so that we can control the speed at which that sweep happens. Okay, so in the last section, we got this sweep working. Let's just close everything down a minute. So within our Arturia callback, we can see that we're first checking whether it's a note on, note off event within our pitch range. If it's not, let's see if we've hit a pad. If we have, go into this control sweep function. We're using a thread now instead so that we can we can carry on doing stuff on the Arturia even while that sweep is happening. And then within our control sweep function here, let's just open all that up. So within our control sweep, it's telling us every time we're coming in at the minute, we don't need that anymore. And it's printing out all these values. I mean, strictly, we probably don't need that. Let me comment that out in case we want it again in a minute. But we want to affect the velocity sensitivity of our sweep. So how are we going to do that? Well, it depends on how hard we hit the note. So in order to know that, we're going to need to pass in data byte 2 as well, because that will be the velocity of our initial note on event back in the Arturia callback. So if I just go back here again, I need to make sure that I'm passing this in as an argument. So let's just add data byte 2 to my arguments list there. And then just before starting our loop here, I'm going to define a variable. We'll call it sleep time. And we want our sleep time to be affected by the velocity that is coming in. So the way that I'm going to do this is say our maximum velocity will be 127. So why don't I say 128 minus data byte 2 times by a value. Now, I'm not sure what this needs to be at the moment, but we'll try out some different values here. Sorry, that should say times. Let's say we hit it with the maximum velocity. This would become 128 minus 127. In other words, 1 times by 0.1. If we were to do a very small velocity, let's say 1, this would become 127 times by our number. In other words, it would give us a much bigger time here. Okay, so if I just copy this variable here, and rather than putting in 0.1 as our value there, we'll put in sleep time. So this will vary depending on how fast we hit our pad. Okay, let's run the script. I'm expecting this to be really quite slow, and we're going to need to speed this up. So get it running and hit the pad. So as we go over into Ableton, in fact, it's so slow, you can see it's barely moving. So why don't we just cut that off a minute. Let's change this value to make it dramatically quicker. Where we go on sleep time. Let's make it 0.001 and we'll try that instead. So let's get the thing running again and hit the pad. So we're looking at Ableton, how quick that's happening. Yeah, that's better. That's much better. So why don't we try, let's try hitting it gently. You can see that's moving slowly. Let's just hit it hard. There you go. And it goes up almost instantaneously. So somewhere in the middle. Yeah. Yeah. Okay. So that's working well. Now you'll notice though, look at the setting in our auto filter on Ableton. Now if I move the knob here, notice what happens. It jumps. Did you see that jump? The reason it jumped is because as far as the Arturia is concerned, the value for that control knob was still in the middle of our range here. Now Python has made it sweep all the way up to there, but Arturia doesn't know that, which means that as soon as we move the knob again, it very quickly jumps back because it thinks that it's at a different value than what it actually is within Ableton. So I guess that's the next problem that we're going to have to get around. So let's have a go at doing that in our next section.